Review sheet E question 2. We have a uniform rod and we've got 20 kilograms here. So I'm going straight down at 20 G. And we're told it's got length 4 meters. So I've got 2 meters, 2 meters. I mean, this is the assumption I'm using here, part B. The assumption I'm using is that the weight acts through the center. I've got an alpha here, and we've been told that tan alpha is 3/4. So that's just the same as last time, isn't it? So you could find out that the angle was 36.9, or you could just write down, again, that the sine of alpha is going to be 3/5, and the cos of alpha is going to be 4/5. There's clearly going to be some resultant force going up at the ground A there, and there's some frictional force stopping it sliding off to the left there. And we've been told that the frictional force, we've been told that the coefficient of friction is 0.5. And so this friction here is going to be 0.5 R because it's in limiting equilibrium. So the friction is at its highest possible point. So the issue with this question is this force here. Because we don't know what angle it's acting at, we're having great trouble with that one there. And so what we're going to do is we're going to actually sort of eliminate it from our work by actually taking moments about B. Let's take that as the pivot. Let's take that as the point we're turning around, because then the distance to this is 0 and things will work. So I'm going to take moments about B. It means I've got to try and think a little bit more about these distances here. So the distance we're going to go to that triangle there, the 20G, I've got the angle of alpha here. I know that's 2. And I'm also going to go across to here with those bits there. So let's go. So we're going clockwise here. Well, the only clockwise force here is all the way over there. So this is 4 meters away. It's R, not 4 meters away. It's 4, and the distance to that force there is this distance here, which is 4 cos alpha. Going anti-clockwise, we've got this weight here. So the distance to that force there is 2 cos alpha, and we're timesing that by 20G. And we've also got another force going anti-clockwise. That's this one over here. So this is the 0.5 R. And how far is that away? Well, that is 4. And that distance to this force here, the distance there to there is that one there, which is 4 sine alpha. So all of that equals 0. And our job is to try and find out what R is, isn't it? So look, cos alpha we know is 4/5. So I've got 16/5 R here. This bit here we can work out. What's this going to be? This is going to be 40G times by cos alpha, which is 4/5. So basically I've got 160 over 5G there, haven't I? 160G over 5 for that bit there. What else have I got here? I've also got sine of alpha here, so I've got a half times by R times by 4, and sine alpha is 3/5. So my grand total there is 12 over 10, or 6 over 5R. And that equals 0. So I'm going to add these two over to this side here. So 16, can I cancel that one down? Let's cancel that one down to 6 over 5. So I've got 10 over 5, which is 2R over here. And I've got 160G over 5 there. So just divide by 2 again. And I've got an answer that R is 16G. 16G is 157 newtons.